Have you ever seen how the Krispy Kreme donut machine works? This is Krispy Automatic Drinking Junior machine.
The Krispy Automatic Drinking Junior was introduced to the public by the Krispy Kreme Donut Corporation in 1950s. It designed to support the production of donut cakes in small retail stores, both in the US and internationally, with a production capacity of up to 60 dozens per hour. The machine became an icon of the transition to home-based industry and was widely used until the late 1960s. It has historical values. Its historical evidence reflecting food, technique, marketing, eating culture in the Southern America. The main reason for choosing this machine as the CAD model, it's besides its historical value, is the fascinating nature of hand surface engineering geometry. This geometry comprises many types of standard components such as hover system, conical shape, batter distribution mechanism, and the conveyor system, all of which require precise tolerance and proportion calculating. Creating this model not only trains students in basic machining commands like extrude, roll, and sweep, but also foster an understanding of assembly.
So in the map, we have exterior design, interior mechanism, animation, encounter problems, and the last one is contributions. In external structure, donut tube we use extrude, revolve, thin wall, and cut. Top tube supports and plate motor we use extrude and round. Top tube we use revolve, delete phases, thin wall, cut, round. Motor support and rod arm we use extrude, cut, round. Motor we use extrude, round, cut, and move phases. More of external structure. Base motor and new base we use extrude, cut, round. Base motor support use extrude, cut, move phases, round. New top base use extrude, cut, pattern, sweep, move phases. Base block use extrude, cut, and the last one is base support we use extrude and round.
Next is external structure. Mixer and spiral bed and steel plate use extrude, cut, and curve technique. Steel plate, fan bed, and holder use pattern, extrude, and cut. Center donut blocking, wiper, and donut stand use only extrude technique. The spin base use only revolve, and the biggest one, the spiral, use extrude, cut, revolve, cut, round pattern in this piece. Joint and hot rod only use extrude and cut. Next is the step to make flippers. From the previous part, we combine all other parts to make this. The flipper to send the 5 donuts into the top base. So the mechanism is first, donut stand are flip. Second, the peak of the spin will take control over donut direction. And finally, the wiper will deliver donut to the top base. And step to make the conveyor system. After the donut has been fried, the top base will spin and send the donut by clockwise and go out of the outlet. And then we get the delicious Krispy Kreme donut.
So moving on to this session, we are going to prove you that our innovation is very suitable to use the vertical travel the plunger as 40 millimeters, and also to prove that we are make the very good excellent mechanical efficiency by the angle of the rotation. So for the first step is that we are going to calculate the stroke length. So as we have a formula that S equal to 2R. So as we design to have the radius of the plate motor at 20 millimeters, so times 2, and the result will be 40 millimeters. So this proves that we are very decisive to make a vertical travel at 40 millimeters. So the second step is that to calculate the transmission angle or the Y max. So as a formula, sin Y max equal to R over L. So basically in the engineer field, we need to calculate the angle of the machine lower than 45 degrees in order to prevent the blinding of your machine. So if you substitute everything from our design, which is R equal to 20 millimeters, and also the L of the machine is 327.25. So as a result, we will got just 3.5 degrees. Therefore, our machine is very excellent for machine efficiency. And the last step is that we are going to calculate the angular velocity or the omega. So as from the formula 2 pi times n divided by our second, which is 60. And by substitute our target, which is 12 donuts per minute, you will got that our omega will be 3.14 radians per second, so which is very suitable and makes sense to make this machine in the real world application. So as a result, this proves that our machine is very well designed to make in each part of the length and also the angle.
It is a simple part. This is overview of animation in isometric view and front view. To assemble, we use relationship ground at new base pair part and at donut tube part. And you will see there's side wheel, top inside wheel, connector and nut. At nut, we use relationship axles allied to assemble it. About animation, we divide animation into 4 parts. First part is flipper animation. First is at donut finish part. This part will rotate limit at 90 degrees and it will speed at 120 degrees per second. It will turning counterclockwise and clockwise. This part will transfer donut from oil into wiper. Next part is wiper. Wiper will limit rotation degree at 180 and the speed 180 degrees per second. It will turning counterclockwise and clockwise. This part will transfer donut from donut finish into conveyor. And next part is donut flip. This part will flip donut in oil and it will limit degree at 90 degrees. Speed is 120 degrees per second and it will rotate clockwise and counterclockwise. Next animation is middle spin animation. This will have fan blade and spin. Fan blade will spin at speed 90 degrees per second and it will rotate counterclockwise. Next part is spin. Spin will rotate 120 degrees per second. It will rotate counterclockwise. Spin will push the donut from donut finish to wiper. And next is depositor animation. We will put rotational motor at motor plate. It will moving in speed 120 degrees per second and clockwise. This will have relationship with rod arm and donut center. Donut center will move up and down to pump the donut. And the last one is conveyor animation. We will put rotational motor at new top base. It will spin at speed 90 degrees per second clockwise. This part will transfer the fried donut to somewhere else.
Next is the problem and solution. We have many problems, but our 3 main problems is first, inconsistency during assembly. So the solution of this problem is we systematically adjust various until all parts were compatible. Second is material overlap and restrict moment. So our solution is we modify part geometry and reanalyze relation to ensure zero interface. And third is unknown rotation angles for the flipper arm in the wiper. The solution is we doing learning by doing approach.
And if you like this video, please make sure to like, subscribe, and send it to your friends to show them how cool the Krispy Kreme automatic linking junior is. See you next time.